Exercise 5, SolidWorks 2019. In this exercise, we're going to take a look at the functionality of SolidWorks with regards to assemblies. We're going to use the bottom-up assembly method, which essentially the parts are all created for us. It's just a matter of getting them off the internet and dropping them in and attaching them using what they call mates. And what you see in front of you is actually the completed assembly. So let's begin. To start, make sure that you go to the vertanu1.com/part-files1, or just go to vertanu1.com and go to part files. In the red column, very top, you'll see exercise 5 parts. Simply click on it. And then once it comes up, it's in a zip format, so it's compressed. You can just go right up here to the upper right, go to the download option. Once it downloads, and I'm using Chrome right now, yours might be a little different. You'll see in the lower left corner, I could actually click on it, and then we'll see it will open up inside my downloads directory. Up at the top here, I could click on extract and hit extract all and specify where I'd like to place it. If I go to browse, I could, I'm going to go to my SolidWorks folder, and from here I'm going to right click and create a new folder, and you could go ahead and name that E5. I'm going to call mine E5X because I already have one called E5. Hit select folder, and it will extract. Hit extract. Now the parts will show up in here, and you could actually just right click somewhere in that view screen and go to view extra large icons, and you'll be able to see all the parts. Go ahead and start up SolidWorks and go to File, New, and select Assembly and hit OK. On the left, if there's any parts that are currently open, they'll be listed and allows you to select from those. In our case, we need to actually direct it to the folder. So I'm going to go to Browse, and I'm going to find my E5 folder. And over here again, if I want, I could click and enlarge these so I can see little images of what they look like. And we're going to start off with the sheet metal bracket. Select it and hit Open. Now, you'll see you can move it and position it on the screen, but I would suggest clicking on the green check mark in the upper left corner. This will drop that part. That part's origin will lock into the origin of the assembly, so they'll match up. The front plane will match with the front plane of the assembly. Top and right planes will all align to each other. And the very first part that you drop into SolidWorks is typically fixed. You could tell by this little F in parentheses. If you were to right click, you have the option to float it, but we don't want to do that. So we're going to leave this currently in its fixed state. Let's begin by adding some additional parts. Go to Insert Component, go to Browse, and let's select the yoke male. Hit Open. And this one, we actually want to drop this not centered on the origin or fixed, just over here to the left, floating by itself. Just simply click, and now it's positioned there. What we can do after you've dropped it in, you could click on it with the left mouse button and drag it whilst you hold the left mouse button, and you'll see it will actually intersect the other part without any issue. Now, up here at the top left, you'll see there's Move Component. If you hit the little arrow under there, you'll see there's Rotate Component. Select that, grab the part, and you can drag that, and it will rotate basically around the centroid of the model, of that specific model. I'm going to hit the green check mark. I'm going to go back and just select Move Component again, and let's take a look. You have some options here as far as positioning. You can put in explicit values in X, Y, and Z, deltas, and so on. We're not going to do that. We're going to leave it at free drag. You do have the rotate option integrated into this, so if you wanted to, you could go to that rotate. There's also dynamic clearance. There's options for standard drag, collision detection, and physical dynamics. As long as the part is not, actually, I'm going to go back here to free drag, but as long as the part's not touching the sheet metal bracket, make sure you move it away, and try collision detection. And over here, if you have a lot of components, you might not want to select all components. It is intensive on the system resources. So if you only have 2, it's not a big deal. But if you had more, you could select these components and select between the parts you wanted to test for collisions, and it would run much faster. But let's go ahead and try this with collision detection turned on. As I grab this and I move it, you can hear when it strikes the surface of the other model, it'll actually give you a ping sound. And so it stops on contact. And it highlights the surfaces that are actually colliding. Let's take it a step further. Let's go ahead and select dynamic clearance. Make sure the part is moved a good distance away. Grab it. Oh, and check clearance between. You have to select both parts that you want to check. Hit resume drag. And now drag it, you could get the distance value as for proximity purposes. And we could also have it stop within a specified clearance. So if we put in we want it to stop within a 1/2 inch of striking the other model, now go ahead, hit enter, resume the drag, and you'll see it will stop within a 1/2 inch before colliding with the other part. There's another option known as physical dynamics, and physical dynamics, I can't really show it here too well, but imagine you had a pool table and you had the cue ball and the other billiard balls out. And if you were to move the cue ball as we move these individual parts, and as it contacted the other components, it would actually push them out of the way. There's no engineering characteristics such as inertia or any other friction that you might experience in a real simulation, but it still does give you a good idea when things get pushed out of the way. So for example, you could use it for gears perhaps. It is very system intensive, so just be aware it might depend upon how many parts you have interacting with each other. It could really get slow. It could slow down. So anyhow, let's go ahead and hit the green check mark, and we'll continue on here. What we're going to do is we're going to establish what's called mates. Mates are similar to relations that we have in sketches, where you can make things tangent to each other or coincident or parallel at a distance and so on and so forth. Let's take a look at some very basic ones. SolidWorks has a little bit of an AI built into it, you might say. In the programming, it won't give you options that you don't have the proper ingredients to take advantage of. So it does make things quite easy in some cases. So let's go to mate, the paperclip up there. Select this pink surface. We want that pink surface now to actually contact this surface here. Now be careful, you can select the edge, and right now I'm hovering over an edge, and you can see it highlights an individual edge there. When we go over the surface, to the right of the pointer we get a square, and that's an indicator that the whole surface is about to be selected. Let's go ahead and select that surface, and what it will do, we'll move the part over, and it will automatically pick, based on some assumptions it makes, what would probably be the most likely solution, and in this case it went with concentricity. If we wanted something else, we could perhaps select that, but just be aware you might not have the proper ingredients on the screen to do that. But let's leave it at concentric and hit the green check mark. And up here in the upper left, go ahead and hit the green check mark to exit the mates. Now let's take a look at what we've just done. Grab the actual yoke with your pointer and your mouse button, hold it down, and now you'll see you could actually drag it up and down vertically, but you can only spin it. It no longer translates or transverses along the X or Y axes. And that's because when we went with the concentric relationship, we've actually removed those degrees of freedom. And ultimately, your goal is to try and remove degrees of freedom to get this in position. However, if you want to simulate what's called dynamic assembly motion, to somewhat see how parts interact with each other, you don't necessarily want to completely remove those degrees of freedom. So we do want to remove its ability to move up and down, but that's about it. We do want it to swivel though. So let's click off of it somewhere, and let's go back to Mate and select this flat face. Now actually I'm going to hit the escape key for a moment, and I invite you to do the same. I want to show you what's called the selection filter. Go ahead and right click in the upper right corner in this gray area here and find selection filter in the lower left, and then it will appear actually as a series of icons in the lower left portion of your screen. What you're going to want to do is you could filter out edges, faces, surfaces, bodies, and all sorts of annotations and such. We're really just interested in, we just want to filter faces, and you'll notice the fast key for that is X, so you could use the fast key instead of using the icon. But now once you hover your pointer over the view screen, you'll see to the right of the pointer there's a little, what looks like a funnel, which is a representation of a filter. And when that's on, just be aware you're not going to be able to select items that aren't options that you had selected on this toolbar. So let's hover over this surface that we want to select. Now try and select the edge. If you hover over the edge, you will not get the option any longer. So that's what we just did. We eliminated that option. You can mate edges. It's just that we'll take a look at that a little later. Right now we're just going to focus on faces. So go ahead and select this face here, and then rotate your model. The way I'm doing it is I'm holding the middle wheel and I'm moving my pointer up, and it's rotating so I can see the underside of the sheet metal bracket. And go ahead and click on that surface of that flange. And one thing I neglected to do was either I could have held Control to select both entities, which I did not do that, so it deselected the last surface. But what's more likely, we should have gone with the Mate. I forgot to select the Mate tool. So make sure you select Mate. And I selected from the Quick Launch. You could also select it up here on the ribbon. Now I'm going to rotate back down with the middle mouse button, and I'm going to hover over this surface and select it. And you'll see, in this case, it went with coincident, a coincident relationship, or Mate. And so it's actually contacting surface to surface on those entities. Let's go ahead and hit the green check mark and hit up here as well. Now try and drag that component. As you grab it with your pointer, and if you try and drag it downward, you'll see that those degrees of freedom, the Z, or actually in this case the Y, are no longer there. It will only swivel in position. And again, we could, in many cases you do fully constrain these entities, but in this case we want to simulate, as I said before, dynamic assembly motions, so we're going to leave this open so it can still swivel in position. Go ahead and hit escape after you've applied that. Let's move on to the next part. Go to Insert Component, go to Browse, and the next part we want is the spider hinge. Select it, hit Open, and get it between the legs of the yoke, and click to release it. You'll see that there's colors on these surfaces. We have blue and we have red. Right now we're just going to focus on the blue surfaces. So for example, this blue surface here and this gray hole, we want to match those up to the holes over here. So let's go to the Mate tool. Select the gray hole that's adjacent to the, or perpendicular to this blue surface. Click on it one time, and then go ahead and select this blue hole on the leg of the yoke. Either hole does not make a difference. Go ahead and select. You'll see it will position itself. Go ahead and hit the green check. And now let's see what degrees of freedom we've just removed. Try grabbing that red surface and dragging it with your mouse button depressed. And you can see it still rotates, but it's not locked fully into position. So I'm going to move that out a little bit and then rotate here. The next mates we should try and apply would be, logically, would be this blue surface right here, and rotate around to this surface here. Now be aware, if you try and select this blue surface, watch what happens. It actually ends up connecting to this surface, and then they're on top of each other. So we don't want to do that. There is an option to resolve this, and it works much of the time, but not all the time. It's called flip mate alignment. That will reverse it. But under certain circumstances, it does have some issues. In this case, I've seen it where it's failed to actually work the way I'd expected. So let's just hit the undo button right here instead, and just make sure we select the proper faces this time. So this face right here, to this face over here. Hit the green check, and hit the green check at the top of the feature tree. And let's zoom out a little bit. Now you can see this will pivot, and then if you release it and then grab the yoke, it will rotate. Let's continue on with the next one. Let's go back to Insert Component, Browse, and this time select the yoke female, and hit Open, and position that right about there. And now we're going to go, and you can see the red faces that we want to attach. So go ahead and select one of the red faces on the yoke female, and go to Mate, and then go ahead and select the gray face perpendicular to the red flat face on the spider hinge. Hit the green check, and now we need to mate those closest faces here. So this red face on the inside of the leg of the yoke to the red face over here directly across from it. Hit Apply and hit the green check. Now let's take a look at what we've accomplished. Go ahead and grab this part. You'll see it swings like a bell. Now what I'd like you to do is position it so that that base of that, what looks like a plunger, there's a little pale green surface there that we want to match to this angled sheet metal flange. So let's go back to Mate, select the angled sheet metal flange. Now be careful, I accidentally had the yoke female pre-selected, so I'm going to right click up here on where it says that, and I'm going to delete that. Now I could go ahead and select the underside of the plunger, that green face, and it should automatically go with parallel. And the reason it went with parallel, if you hit the green check here and here, hit your space bar on your keyboard and go to the right view orientation. Oh, I'm sorry, not the right, go to the front view orientation and zoom up, and you can see the reason it picked parallel is because there's actually a distance gap between the two. And this is a very likely scenario when you're modeling assemblies. There's always a little clearance between them, or tolerance. And there is a tolerance stack analysis tool inside here. We're not going to cover that right now, though, but be aware you could probably find a YouTube video or two that shows you how to use that if you're interested in tolerance stack analysis. Right, now we're going to go ahead and take a look at what we've done. Grab this top pink surface here with the pointer and make a small little circle as you draw around here, and you'll see the parts are interacting with each other, and this is what we call dynamic assembly motion. It's not a full simulation, but again, it's not giving you friction or any sort of kinematics data. It's just strictly dynamics. Now what we're going to do is we're going to put in some pins here. So another option, instead of going to Insert Component, is to actually go and find your folder here. And if you have dual screens or multiple screens, this is an excellent option, what I'm about to show you here. You could actually have all of your parts here. Let me go to View and View Large Icons, make them a little bit smaller so I could squeeze this down to fit on my screen. And you have yourself a little library that you could access without having to use the tool as I was showing you before, where Insert Component and Browse. Now you could just simply grab these and drag them over. And we could have done this from the very start. I was just showing you the general way of doing it, but now you can see here we're going to go ahead and grab a red pin and drag it in. Now the neat thing when you do this, get it close in proximity to where you want to drop it and release it. And now we could go ahead and go to Mate, click on this surface here, to this surface. So basically you're going to select the red shaft to the red hole and hit the green check. Now to push it in, you'll notice you can grab it with your pointer and drag it in, but that's still going to float. What we want to do is we want to get this flat end of the red pin tangent to this black surface on the outside of the yoke, female. So let's go ahead and select that surface, and you'll see it will automatically push in, and look at the option that it's selected automatically for us, tangency. So now that flat surface is tangent to the exterior of the yoke. So it's flush. Hit the green check, and hit the green check up on the mate tools. And so now we've inserted our red pin. Let's get a little more complex here and bring up our tools again. And again, you're welcome to go to Insert Components and browse for these parts if you don't like it on single screen here. But let's go with the blue pin now. And let's try that one more time. Drag that in and just drop it right there. And let's go ahead and select this surface. Go to Mate and select the blue surface. Hit the green check. And again, this one we're going to make tangent. So select this end face of the pin and this gray face of the yoke male. And it should automatically go with tangency. Now if it's flipped to the opposite side, try using flip mate alignment, and that will rotate it 180 degrees. Most of the time it's successful, but there are times when you might have a collection of mates that it doesn't. It makes it non-conducive. So let's go ahead and hit the green check. Now what I'd like to do next is show you another technique for inserting parts, and this adds some additional functionality. Let's go back to the E5 and let's double click on the blue pin. And it should open up the blue pin in its own view screen. And we could go to Window and Tile Vertically. And now we could see, we're going to get rid of this one right here because we don't need that. That's an old one. And now we could hit Window, Tile Vertically again, just to maximize screen space. Rotate this around the assembly so you can see the back side, and you can see that blue hole. And grab this blue cylindrical surface and drag it into the hole, and you'll see you'll get some little symbols to the right of your pointer, two concentric bodies that are aligned. So go ahead, when you have that, release it, and now you've automatically established a concentric mate just by dragging it in that way. Now we could go ahead and click on this surface, go to Mate, and select this surface to make it tangent. Hit the green check. You could close that pin, and you don't have to save it. Oops. I shouldn't have discarded those changes, but that's okay. All right, the next thing we're going to do is we're going to go ahead and drop in a subassembly. So the subassembly, we'll maximize this, and we're going to go ahead and we'll actually bring that through the Insert Components here. And let's go ahead and select the handle subassembly. Now be careful, this is an assembly document. There is something called the handle, and it's part of the handle. It's the base, so you don't want that part that's next to this. So we want this assembly. Hit Open, and just click up here to release it nearby the top of the head. And you could grab that. Notice it moves as one, and if we look at the feature tree, you'll see that subassembly is recognized, and there's two parts. There's the handle top and handle. So let's go ahead and mate this. Go to Mate, select that cylindrical face there to this face here. And now drag this up and find the yellow flat face right here. Now be careful, there's a radial yellow face. Stay away from that one. You want this flat face. And that notch, so basically a keyway, you want to select this face right here to align the two. And notice I was in Mate while I did that. Now you'll see this underside green ring. Select that surface, and then go ahead and select the top surface of the sheet metal bracket. Now, on here we see there's a distance option. Go ahead and select that. We could specify how far we want it to be positioned, and again, this is a more realistic approach. Generally with parts, they're not always going to be line-to-line fits. Actually, very rarely they're line-to-line fits. And so this one, we have accommodations for distance gap between those two surfaces. So let's go ahead and set it at 0.01 and hit enter. And you'll see it will reposition itself, hit the green check. And if you rotate around, you'll see there's a slight distance gap between the two that we've added. Hit the green check. Now, we're going to, that pretty much concludes this. There are some additional holes for set screws. If you want to challenge yourself, you could bring in the set screw. I'll start off with one of them. I'm going to go over here, select the fastener, and just hit OK there and get it close to position where I want it. Hit escape and rotate. And now we want to lock that in. So I'm going to show you another little neat trick. If you hold the Alt key and then depress your mouse button on the thread, drag it to the surface of the hole, and you'll see it will position itself. And release it. Now if you need to flip it, there's a flip mate alignment. You could hit that and then hit the green check mark so that the socket is facing outward. Now go ahead and let's repeat that again. Hold Alt and select this surface and drag it to this flat surface. Hit the green check and hit escape. Now you could do it the traditional way that we just went through. If you want to make a copy of this, here's another little trick. Hold Control, grab that, and drag it out, and you could get it close again in proximity there. So just holding the Control, you can make additional copies of the part. And we'll do this more traditional method. We'll go to the Mate tool and select the hole to align to, and then this face to this face right here. And you could go through and add the additional ones if you like. That pretty much concludes that exercise. Now the lab, which is in the training guide, if you go to the Britannia1.com, go to instructional manuals and SolidWorks Basics, it'll be under the exercise 5. And I'm going to scroll to that. And Lab 5B, as you can see here, is this Bluetooth headset assembly. And you're going to need to download these parts, and you can do this directly from the site. Go to Part Files, and you'll see Lab 5B parts. Just click on that, and again, these are compressed. Just download them as a zip file, and then click on it once they're downloaded. And over here, hit Extract, Extract All, and direct them where you'd like them to be. Like in this case, it's going to create a Lab 5B folder. You can go ahead and hit Extract, and now we actually have them in a tidy little folder that we could just drag and drop from. So let's begin. Let's bring up SolidWorks here and start a new assembly. Hit OK. And I'm going to hit Cancel here, and I'm going to use the little method we saw earlier where we could just drag and drop these in. So I would recommend starting with the rear bezel. You just drag and drop that in and hit the green check. And you'll see it's fixed in space, so now we could drop other parts in as well. So I would bring in the circuit board or the PC board at this point in time. Just drop it in. And you can mate these. Now you could use the trick of the Alt key if you like. Grab this surface here, hold Alt, drag it to this surface here, release it, hit the green check. Do the same over here. Now be careful, there's two sets of holes. That one's for the light pipe. We're not going to do that later. Hold Alt, drag this to this surface here, release, and drag this up now. And you could just go to the paper clip if you like and select the underside surface of the green board to this tier right here. Hit Apply. Let's bring in the next part. We're going to bring in the battery shield. Drag and drop that in. And we'll go to mate. This underside surface here to the top of the rubber grommet right here. The green check. It's not going to position itself. Drag it over. And now we can mate this cylindrical face to the face of the rubber grommet. Don't forget to turn off your selection filter also. In my case, when I started up a new assembly, it automatically did that. But just remember to turn it off. You can just deselect it, or deselect this one right here. And let's bring in the batteries now. I'm going to go ahead and grab a battery cell. In this case, use a temporary replacement font. And then we could go ahead and position this again with the Alt key, drag this to this surface here so it aligns itself, drag this up, and now select this face, and go to Assembly, Mate, to the underside face of the battery. And I'm going to go ahead and show you a little trick for patterning parts. We need 4 of these stacked on each other. So you can select the part. You can go to linear component pattern. Select like an edge right here for the direction. So we're just selecting a vector essentially. So it can be any one of these edges. There we go. You can see the arrows pointing up. So it's going to stack them upward. Put in the distance, and it's 0.06. And we want 4 of them. And you can see as you increase the number, you can see the preview shows them stacked. Hit the green check. So there we have assembly patterns. Now we'll go ahead and bring in another part. Let's bring in the connector, drag that in, escape, and let's go to mate, select this face here to this surface here, and then drag it up, and then this surface here to this surface here. So they're like stacked, and straighten that out. Now let's bring in the light pipe now. The light frame. Just drag that over here. Now transparent objects can be a bit tricky to work with. If there's something behind it, it selects through the transparent object. So Shift will allow you to select a transparent object if you're not able to normally. But we don't really need it just yet. But let's go to Mate. I'm going to go ahead and mate this edge now to this flat green surface here. And then I'm going to go ahead and select this surface here to that hole. And you'll see it's difficult to select now because it's transparent. If you hold Shift, you should be able to grab it, and you'll see that that is still floating a bit. So I'm going to hold Shift and select this face, and then to this face right here. And now the light frame is secure. Let's get the other part on here. Find the front bezel, drag that in, and we'll proceed with mating this. Let's select this face to this face. We'll pull that up a little bit, and then this face to this face. Be aware you can't select the fillets to mate to. And then let's go back to mate. And then this face here to the top of this flange. And there should be a little gap between it. Okay, now we're going to take a look at how to explode this. Exploded views are very useful for drawings especially, or anything. Go to Exploded View, select this part. You'll see you can position in X, Y, and Z. We're going to grab the Z arrow with our mouse button depressed, drag it forward. You see a little ruler so you could accurately position this. Let's go 4 inches roughly. And then click on the rear bezel. And unfortunately, you'll see the rear bezel was part of that last move. I meant to deselect that. So I'm going to right click on that, delete the rear bezel from that. I'm going to click off of this, and I'm going to click on this one, drag it backwards 4 inches, and then click off of it. And unfortunately, I got to delete that one there. Okay, now I can click on it, drag it backwards, and then usually, let's see, let's hit OK. And they seem to have changed the exploded view, the way it works a little bit, and it's just not working the way I had anticipated. So my apologies, I didn't practice this in advance. So, but basically, you can actually deselect and reselect them. I'm going to do that one more time. Now you can actually edit the old exploded view if you go to Configurations, Property Manager up here. Hit the little arrow to the left of that. There's the exploded. Just double click, or actually right click, and hit Explode. And now we should be able to select this and continue on. Let's see here. Let's edit the feature. There we go. Select this part, drag that forward. I'm going to right click to apply it, then I'm going to click on this, drag that back, right click to apply it, click on this, drag it forward, and again right click to apply. So that was what I was missing, was just a simple right click. Drag that back, right click to apply, drag this, right click to apply, hold that, drag that forward, right click to apply. And there we have our exploded view. Hit the green check. Be aware, if you go to exploded view, it will reset and create a new exploded view. It's a very nice tool, actually. It might, for a new user, it might be a little bit of a challenge to understand, but what it's doing essentially is, so if you're making a catalog for assembly or disassembly of something, you can make multiple exploded views to demonstrate that. Then you're able to actually animate this. So if you right click, and actually let's go back to the feature manager up here. Go to the very top, and if we right click at the top of the assembly, you'll see there's collapse, and there's also animate collapse, and you'll see it will animate this for us. With the animation controller, we have the ability to set it to reciprocate and hit play again. You'll see it will explode. We could have it at half the speed or twice the speed, and you could even do a loop. And then finally, you could save the animation and save it as an AVI, and there's a series of codecs depending upon what you might have on your system. You could output that for a video. And that concludes the lab.